Alright, this is the video lecture for Physical Science, Chapter 4, Unit 2. We're going to be talking about energy, what it does, and a couple of different kinds of it, as well as how to manipulate the kinetic energy equation and the gravitational potential energy equation. We saw both of those when we did our egg drop experiment. Alright, so once again, I'm going to be going off of the slides that you have available to you in Google Classroom. If you've got any questions about any of this stuff, send me an email. It worked pretty well last time. So go ahead and use the resources you have to you as much as you can, all right? If something's giving you a hard time, you need to go back and watch it again. Hit pause and rewind this, all right? If you need anything video quality or audio-wise, let me know. I can make some adjustments. All right, so if you're in the textbook, this starts on page 114. All right, so energy is the ability to do work or cause any change. It is related to the first law of thermodynamics, which we've kind of talked about in the past. It's much like all the other conservation laws, where energy cannot be created or destroyed. All right, this transfer of energy is work. All right, so when energy is transferred from one object to another object, or from one type of energy to another kind of energy, that's work, right? Which we talked about last time. The law of conservation of energy, of course, is one of those things that God is the only one that's able to break, and we attribute those to miracles. All right, so potential energy versus kinetic energy. We kind of talked about this with the egg drop, right? We talked about gravitational potential energy, where it depends on the height or the position of the object. But there's also potential energy that's based on the shape of an object, like a spring. If you pull a spring, it wants to go back to its original shape. If you compress it, same thing. These can also be considered elastic potential energy, with like rubber bands and springs. There is chemical potential energy, like in batteries or in food. Remember, your body's digestive system breaks that down into usable chemical energy. And then we even have magnetic energy, with the energy that magnets use to pull themselves closer together. We may get to talk about that towards the end of the year. It depends on the pacing. I have no clue how fast we're really going to go as we move along with this distance learning thing. Kinetic energy, though, kinetic energy is only movement, period. That's it. It doesn't matter what's moving. It doesn't matter how fast. It's still kinetic energy. All right, and kinetic energy we are going to calculate with the kinetic energy equation. Ke is kinetic energy. It is 1/2 of the mass of the object. This needs to be in kilograms, times the speed of the object, right? And this is going to be in meters per second, right? And we measure this in joules, right? So to get joules, you've got kilograms times meters per second squared, or meters squared per second squared, because we're going to be squaring that, all right? In the textbook on page 116, I'm going to work through number 16, and I want you to try to work through number 17 on your own. I'm going to give that answer at the end of the video. All right, so number 16 says a baseball with a mass of 0.15 kilograms is moving at a speed of 40.0 meters per second. What is the baseball's kinetic energy from this motion? All right, so it asks us for the kinetic energy, so that's going to be our unknown. 1/2 is a constant, so we don't change that. Then the mass of the object was 0.15 kilograms. All right, that's 150 grams, so regular sized baseball. And its speed is 40 meters per second. So because this square is on the outside of this set of parentheses, it applies to everything inside. So we're going to do 40 squared and meters per second squared. All right? So meters per second became meters squared per second squared. 40 became 1600. I can't do half of 0.15 in my head. Well, I can. It's 0.75. But you could also apply it to this, which is what I'm going to do. All right, go ahead and hit pause, put this in your calculator, see if you can get the answer. You should get 120 joules. Remember, because kilogram meter squared per second squared is joules. We talked about that before. All right, so 120. I want you to try number 17. You're just going to do 2 of these. You're going to do one for the faster speed and one for the slower speed, and then you should be able to divide them to tell me how much bigger the energy is of one to the other. All right. Gravitational potential energy is one we've already talked about with the egg drop, right? It is the energy that something has due to its position above the ground. It really only activates this energy or uses this energy when it starts to fall. Remember, potential energy is kind of like an unused energy. It's stored, right? So we're going to use the equation GPE equals mgh. So gravitational potential energy equals the mass of the object. This needs to be in kilograms. G, that is the gravitation on Earth. So that's 9.81 meters per second squared. And H is the height of the object above the ground or whatever object will stop its fall. So if I hold something above like a table and drop it, the energy used in that fall is just to the table. So we would use this height distance, not from where it is compared to the ground. All right. And for a practice problem for this, we're going to look at page 119, and we're going to do number 18. So number 18 reads, an 8.0 kilogram history textbook is placed on a 1.25 meter high desk. How large is the gravitational potential energy of the textbook Earth system relative to the floor? So when it says textbook Earth system, that means we're comparing it from the textbook to the Earth. So where the textbook's position is to the surface of the Earth instead of like a table. All right, so number 18. We are solving for gravitational potential energy. The mass of the textbook was 1.5 kilograms. The acceleration due to Earth's gravity is 9.81 meters per second squared. And the height was 1.25 meters. All right, I can't do any of that math in my head. You probably can't either. So hit pause, put this in your calculator, and try to solve. So the answer should be 98 joules. Again, we're going to do this meters times that meter squared to get meters squared per second squared. Multiplying by kilograms, that gets us to joules. All right. I think you can do number 19 pretty easy. But you need to consider the textbook Earth system relative to the desktop. So think about how far that object is going to fall to hit the desktop, if it's already on the desktop. Should be pretty easy. Once again, I'll answer that in a couple of seconds. All right, so these are our two main types of energy we're going to talk about today, kinetic energy and gravitational potential energy. There are other types of potential energy. Springs are something that we might introduce next week, depending on how we do with this stuff. But I want you to be able to tell the difference between them, so differentiate them, and describe where that energy comes from. So the energy in kinetic energy comes from the speed and the mass, right? Kinetic energy equals 1/2 the mass times the velocity squared. And the energy in gravitational potential energy comes from the height of the object, the acceleration due to local gravity here on Earth, and the mass of the object, all right? It comes from that attraction and the difference in height, the distance between them, all right? So take your time with this stuff. If you have questions, send me an email.